Good evening, students. Am I audible?
Yes, sir. Audible.
Okay. So I'll just give you 5 minutes time. I want you all to go through the concepts of capacitors and be ready. I'm going to solve the problems from them. Okay. Yeah. Are you able to see my screen?
Yes, sir.
Okay. Like as mentioned, no, please switch on your videos. Everybody. Others also. Yes. Screen is not visible. Are you able to see my screen? Yes. Yes. What is the issue? I think I have some internet issues. Yes. I think it will be fine now. Yeah. So look at the first question. So we'll be doing the problems which are based on capacitors and all our previous year questions. Okay. So the first question that we are going to see here is the given graph shows variation of charge Q versus potential difference of two capacitors C1 and C2. Both the capacitors have the same plate separation, but the plate area of C2 is greater than that of C1. Then which line corresponds to C1 and why? So if you observe the question clearly, there is a graph that is drawn between variation, showing the variation of charge versus the potential difference, right? Both the capacitors have the same plate separation. So if I take them to be the parallel plate capacitors, the distance of separation between them is same. Right, the distance of separation is same. But what did they say? The area, the plate area of C2 is greater than that of C1. Okay. So the plate area A2 is
greater than A1. Wait, let me change the color. Yeah, plate area A2 is greater than A1. Now, which line corresponds to C1 and why? So, how to solve this? First of all, when you look at the graph, right, the graph speaks about the relation between Q and V. So, how can we use Q and V to define the capacity?
C is equal to Q by V.
How can what is the relation between just give me a minute. Am I audible, guys?
Yes, sir.
Sir, you're not audible.
Yeah, now am I audible?
Yes, sir.
Yeah. So with respect to the graph that is given, can I say that Q by V is the slope because y-axis divided by x-axis is going to be the slope? But what is Q by V according to physics? Q by V is going to be the capacitance. Am I clear till this point? Now, tell me, how is the capacitance for a parallel plate capacitor defined as? C is equal to epsilon naught A divided by D. So greater is the area, greater is going to be the capacitance. So among the graph A and B that is given to us, which one has a greater slope? Which one has greater slope? Greater slope is greater angle. A. So answer should be A. No. The plate area of C2 is greater than C1. Sorry. The plate area of C2 is greater than C1 means C1 has lesser slope. So answer should be B. So let's connect all the dots again. This is one such rare question where they'll give you the graph. So when they give you the graph, if Q is taken on y-axis and V is taken on x-axis, then Q by V will give you the slope. So Q by V is slope according to mathematics, but the same Q by V is going to be capacitance according to physics. Okay. Now, there is another condition that is given. The distance of separation between them is given and the area of cross section of each plate, if it is taken as A1 and A2, then A2 is greater than A1. Means greater is the area, greater is going to be the capacitance. So among C1 and C2, whose capacitance is more? Among C1 and C2, whose? Yes, C2 is more. So C2 should have a greater slope. So the graph A corresponds to C2 and the graph B corresponds to C1. Am I clear with this? Yes?
Yes, sir.
Shall I proceed? So line B corresponds to C1. So what about the 29th question? If you see, figure shows two identical capacitors C1 and C2, each of 2 microfarad capacitance, connected to a battery of 5 volt. Initially, the switch S is left open and dielectric slabs of dielectric constant K is equal to 5 are inserted to fill completely the space between the plates of the two capacitors. How will the charge and potential difference between the plates of the capacitors get affected after the slabs are inserted? So for solving this question, you need to look at the table that I gave. So check your notes and go to the table. Remember the table? Capacitance when dielectric is inserted, without battery, with battery. So observe, initially when the switch is opened, right, observe, there is a battery connected here of 5 volt. So when the switch S is opened, the charge flow across which capacitor is getting affected? Is it across C1 or C2? Which capacitor stops to receive the charge?
C2.
It is C2, correct. So what about C1? C1 is receiving the charge. Okay. So what is going to be the charge that is appearing on C1? So I'll call it as Q1. Q1 is equal to C1 into V1. So Q is equal to CV. Q1 is equal to C1 into V1. C1 is 2 into 10 power minus 6 into what is the value of V1? It is going to be 5. The answer is going to be 10 into 10 power minus 6 coulomb, or there is going to be 10 power minus 5 coulomb. That is going to be the charge on the first capacitor. Am I clear with this? Now, what about the charge on the second capacitor? What about Q2? So Q2 will be equal to how much? That will be C2 into V2. Okay. It is going to come out to the same value, 10 power minus 5 coulomb. So this is what would have happened when the switch S would have been closed. Right. Now look at the table and tell me what will happen when the dielectric, what will happen to the charge when the dielectric is inserted and the battery is connected. Check the table and tell me.
C not V not. K into C.
Correct. For which one it will be K to C not V not. So
Battery connect.
yes, which one is connected to the battery still? Q1 dash will be equal to K times Q1. That will be 5 into 10 power minus 5 coulomb. Makes sense? What about Q2 dash? When the battery is disconnected, what will happen?
This,
It's the same. Is it not Q2? So answer should be 10 power minus 5 coulomb. Right. Now, what about the potential difference between the plates of the capacitors? So the first one is connected to the battery and is still connected to the potential source. So what is V1 dash? Dielectric inserted and the battery is switched on. So what is V1 dash?
Q1 receiver.
Check the notes, ma. Check under potential. Okay. Check under what will happen under potential and battery disconnected and connected with the dielectric. potential, battery disconnected, battery connected. What is happening in your notes? Is that not there, the table?
So for battery connected, it is V0 and disconnected V0 by K.
That's what I'm asking. So for which one is the battery still connected? For C1.
C1.
For C1, the battery is still connected. So what will be the potential across it?
V0.
How much is that V0? What is the battery you are able to see in the diagram?
5.
5.
That's the answer. So V1 should be, sorry, V1 dash should be 5 volt and V2 dash should be 5 divided by 5 volt, which is 1. That is what the question is all about. That is what they are asking. Are you able to understand? So this is all you need to know. As I told you, this kind of a problem is important. This was asked, as far as I remember, it was asked in 2018 for 3 marks. It's a very simple problem. See, you just remember the table, you can write it in 2 steps. I've informed others also to keep your video on. I just want to see what is happening. Catherine, Kalpagesh, Laya, Neha, Prakash, Shrikriti, Divya, and Shrikriti and Divya. Keep your videos on. Or else I'm saying I'll just put you in the waiting room. I'll not let you come and sit. You guys neither speak or I don't know what is happening on the other side.
Sir, can you hear me, sir? Sir, வீடியோ ஆன் பண்ணா இது உங்க எல்லாமே பிரேக் ஆகுது சார் வாய்ஸ்லாம்.
அப்படியா?
சார் புரியல.
Bandwidth issue.
இருக்கும் சார், அது என்னன்னு தெரியல. பட் வீடியோ ஆன் பண்ணா உங்க எல்லாமே ஆஃப் ஆகி அப்படியே சைலண்டா இருக்கு சார் ஃபுல்லா.
Okay. Okay. But others keep it on. So did you all copy it? Did you all copy the question answer? Yes. So net capacitance of 3 identical capacitors in series is 1 picofarad. What will be their net capacitance if they are connected in parallel? So observe, read the question. There are 3 identical capacitors which are connected in series. Right. So the equivalent capacitance of this kind of a connection is 1 picofarad. What will be their net capacitance if they are connected in parallel? So what is that you need to do first of all? You need to calculate what is the individual capacitance. First find that. So what is individual capacitance? It is
10 to
3
the power.
3 picofarad.
It is 3 picofarad. Now, if there are 3 picofarad capacitors connected in parallel, so what will happen in the parallel connection? It will be 9 picofarad. It will be 9 picofarad. Find the ratio of energy stored in the 2 configurations if they had been connected to the same source. So So energy in the first case will be equal to half into what is the equivalent capacitance? 1 into 10 power minus 12 into V square. U2 will be equal to how much? Half into 9 into 10 power minus 12 into V square. So U1 by U2, they both get cancelled. 10 power minus 12, 10 power minus 12. Answer will be 1:9. Because they asked the ratio. Is that clear? So next one. Solve this. Determine the potential difference across the plates of the capacitor C1 of the network shown in the figure. Assume E2 is greater than E1. We need to find what is the potential difference across the network. See, but this question you will not be able to solve because I need to teach you cells in series and parallel. So let's leave this. Because the net EMF will be E2 minus E1. You need to know this only, then you will be able to solve. It's fine. I'll explain this after we complete the cells in series and parallel in next chapter. Do this one. Where is the figure? There's the diagram. So a network of 4 capacitors, each of 15 microfarad, is connected across a battery of 100 volt as shown in the figure. Find the net capacitance and the charge on the capacitor C4. So first part of the question is find the net capacitance. So how to find the net capacitance? We know that C1, C2 and C3 are in series and the combination is in parallel with C4. So for C1, C2, C3 being in series, what is going to be the equivalent capacitance? So what is CS? Since C1, C2 and C3 all are identical, it is going to be 15 divided by 3. So it will be 5 microfarad. So it is like this 5 microfarad is connected across the 15 microfarad in parallel. This 5 is connected across the 15 in parallel, and this is going to be 100. So 5 and 15 are in parallel means what is going to be the equivalent capacitance in the parallel connection? It is going to be 5 plus 15, it is going to be 20 microfarad. So the equivalent capacitance of the network is going to be 20 microfarad. Am I clear with this? Right. Now, the next part of the question is they are asking what is the charge across C4? What is the charge across C4? So if I call that as Q4, Q4 is equal to C4 into V4. What is the value of C4? 15 into 10 power minus 6 into what is V4? What is the potential difference appearing across the 15 microfarad? It's 100. So answer will be 15 into 10 power minus 4. So 15 into 10 power minus 4 coulomb, or it can also be 1.5 into 10 power minus 3 coulomb, which will be considered as 1.5 millicoulomb. Clear with this? Okay. Next one. Shall I proceed?
Yes, sir.
So this one, there is a network of 4 capacitors, each of capacitance 30 picofarad is connected across a battery of 60 volt as shown in the figure. Find the net capacitance and the energy stored in each capacitor. I'll give you 5 minutes time, solve this fast. It is similar to the previous problem. Anybody with the answer? What is the net capacitance?
40 picofarad.
Yeah, net capacitance will be 40. You will get 10 plus 30. Correct? So net equivalent capacitance is 40 picofarad. What about the energy stored in each capacitor? For you to calculate the energy stored in each capacitor, right? For you to calculate the energy stored in each capacitor, you need to calculate the potential across each. So what will be the potential across each? Across C4, how much is going to be the potential? It will be
60.
60. Across C1, C2, and C3, how much is going to be the potential?
60.
Twenty.
It will be 20. Because across the series connection, C1, C2, and C3 are in series, right? Across the series connection, the potential will get divided. So since all the three are equal values of capacitances, you can directly say that the value here will be 20, 20, and 20. So now you know the potential across each and you know the capacitance of each. Just calculate the value and tell me. So basically, if you calculate for C1, the energy is going to be the same for C2 and C3 also. Similarly, calculate for C4 separately and tell me those values are. Did you all understand what I told you?
So 6 into 10 power minus 9 joules for C1, C2, C3 and
6 into 10 power.
minus 9.
So basically U1, U2, U3 is 6 into 10 power minus 9 joule. Is that right? So let me calculate and see. Half into 30 into 10 power minus 12 into V square, that is 400. Correct. So it will be 600. Correct. Then what about U4?
So it's
54 nanojoule.
minus 54 minus
54 into 10 power minus 9 joule. Are you sure that is a value? So my question is, here also you got 10 power minus 9, here also you got 20. Oh, 54 into 10 power minus 9. Okay, okay. That's possible, but why is the answer given as 10 power? See, basically there is a mistake in the solution. They took the value in terms of microfarad, but actually the question is given in terms of picofarad. Your answer is right. We will go with whatever is given to us. Your answer is right. This is another question which is based on the concept of a redistribution of charge. Okay, there is a parallel plate capacitor of capacitance C which is charged to a potential V. It is then connected to another uncharged capacitor having the same capacitance. Find out the ratio of the energy stored in the combined system to the energy that is stored initially in the single capacitor. So draw the diagram for both the cases and then try to solve this. So what is the initial energy stored in the first capacitor? U1 is how much? Half? I'm expecting an answer. Half?
CV square.
Half CV square. So when this capacitor, which is charged, is connected to another uncharged capacitor, see, for example, this is charged to a potential V. This is having capacitance. Initially, the charge is 0. When will the charge from the bigger capacitor to the smaller one stop flowing? When they're attaining a Sydney, unmute and speak.
And equilibrium.
Sorry, when that is common?
Equilibrium.
There is something called as common potential.
Okay.
Yeah, there is something called as common potential. If I call that common potential as V dash, that will be C1 V1 plus C2 V2 divided by C1 plus C2. I showed you the derivation already. So C1 is how much? C into V divided by C1 plus C2 is 2C. Answer will be V by 2. Obviously, right? So here the potential should be V by 2. Here the potential will become V by 2 in the final situation. So what is U2? U2 is the sum of the energy stored in C1 and C2, which is going to be half C into V square by 4 plus half C into V square by 4. So what will be the answer? It will be 1/4 of CV square. Makes sense? So it is 1/4 of CV square. Now what are they asking? Read the question carefully. Find out the ratio of the energy stored in the combined system to the initial energy in the capacitor. So it is U2 divided by U1. So 1/4 times CV square divided by half CV square. This will cancel this 2 times. So CV square and CV square are gone. Answer will be 1:2. So energy will actually fall by a factor of half. This we have seen also many times. Like we did 2 problems based on this. One was the example problem, one was the exercise problems. In both the cases, if you see, right, initial energy would have been double the final energy. That is how it works. So if at all this kind of a question comes in MCQ, you can remember it as 1/2. But you need to be careful with one thing. If they ask you the ratio of the final to the initial, it is 1/2. If they ask you the ratio of the initial to the final, it is 2:1. You're clear with what I'm saying? So this is very, very important to be noted. So basically, energy final divided by energy initial is 1/2. Energy initial by energy final is 2/1. Okay. Next. Try solving this. There are 3 identical capacitors C1, C2, and C3 of capacitance 6 microfarad, each connected to 12 volt. Sorry. 3 capacitors C1, C2, and C3 of capacitance 6 microfarad each are connected to a 12 volt battery as shown in the figure. Find the charge on each capacitor. So tell me one thing, which capacitors are connected in series and which one is in parallel?
C1 and C2 in series and C3 in parallel.
C1, C2 are in series, right? And C3 is in parallel. So this C3 is directly connected across the battery. You're able to see how to identify this is you have the positive potential here, negative potential here. The same positive will appear here and negative will appear here. So C3 is directly connected across a 12 volt capacitor. Sorry, 12 volt battery. Am I right? Now, what is going to be the charge on the third capacitor? It will be C3 into V3. What is the capacitance of it? 6 into 10 power minus 6 into what is the potential difference across C3? It's there in front of our eyes. It is 12. So it is going to be 72 into 10 power minus 6 coulomb. So that is the charge appearing on the capacitor C3. Whereas for C1 and C2, if you observe, no, the 12 volt gets broken into two parts. How much will the value be?
6.
So it will be 6 here and 6 here. Based on that, calculate Q1 and Q2 and tell me. So Q1 is equal to C1 into V1. So C1 is 6 into 10 power minus 6 into, what is the value of V1? It is going to be 6 volt. So answer will be 36 into 10 power minus 6 coulomb. So this is going to be the same value for Q2 as well. Correct. So Q2 is also going to have the same value. So the first part of the question is over. We have found the charge on each capacitor. Now, how to find the equivalent capacitance of the network? You already told me one thing. What is it? C1 and C2 are in series and C3 is in parallel. So since C1 and C2 are in series, what will be the equivalent capacitance in series connection? CS will be equal to C by 2, which is going to be 3 microfarad. Am I right? What about C equivalent? So the diagram will get shifted like this. This is 12, this is 3, this is 6. So 3 and 6 are in parallel. So it will become 9 microfarad. So the equivalent capacitance of this network is 9 microfarad. Right. And the third part is energy stored in the network of capacitors. So how is the network replaced as? Network is replaced as if there is a 9 microfarad capacitor connected across a 12 volt battery. So there is a 9 microfarad capacitor connected across a 12 volt battery. Right. Then how much is going to be the energy? Energy is going to be half C V square. So this is going to be 72. So what is 72 into 9?
648.
648, no? So 648 into 10 power minus 6 joule. So this is going to be the answer. I hope I'm clear. Okay. Shall I proceed? So let's check the answer. For C3 to 72, then we got 36, correct? The 9 microfarad. 648 into 10 power minus 6, no? Yeah, it's the same as 6.48 into 10 power minus 4. Both are same. Okay, I'm doing one last problem. So two parallel plate X and Y capacitors have the same area of plates and same separation between them. X has air between the plates while Y has a dielectric medium epsilon R between the plates whose value is 4. Calculate the capacitance on each capacitor if equivalent capacitance of the combination is 4 microfarad. So basically, if you observe this question, if I take this X capacitor and this as Y capacitor, if the capacitance here is C naught, what will be the capacitance of Y? It will be K times C naught, where K, the value of K is 4. So instead of epsilon R, I wrote it as K. Okay. Now calculate the capacitance of each capacitor if the equivalent capacitance of the combination is 4 microfarad. 1 minute. How are they connected? No, but one thing that is not mentioned here is, are they connected in series or parallel? So solution says they are connected in series. We'll take it as series. So if they are connected in series, then what is going to be the equivalent capacitance? That's what we need to find. So when two capacitors are connected in series, I told you the equivalent capacitance will be C1, C2 divided by C1 plus C2. So that implies C naught into Kc naught divided by C naught into 1 plus K. So this value is equal to 4 microfarad. So C naught and C naught will get cancelled. The value of K is 4. So 4 times C naught divided by 5 is equal to 4 microfarad. Cancel this and this. So C naught will be equal to 5 microfarad. So the capacitance of X capacitor is 5 microfarad. What will be the capacitance of Y? If this is 5 microfarad, what will be the capacitance of Y? It will be 20 microfarad. But I think the question is incomplete. There is something missing, I think. See, this part is okay. This we solved it. Calculate the potential difference between the plates of X and Y. So I don't know what is the value which is connected. So it is difficult for us to calculate. I think the question is incomplete. I'll check this part. So this one alone, I hope the first part is clear to you, right? First part is clear?
Yes, sir.
Okay.
Yes.
Okay. The second and the third part alone, I'll explain it. I'll have a look at it. I doubt there is a mistake. Because unless I know how much is like how are they connected across any external device, we can't tell how it works. Okay. There are few other problems as well. So this sheet will be uploaded in the app today. You can have a look at all these problems. There are solutions also given. So if you have any doubt, you can reach out on the student support number. Okay. So with this, we'll wind up. Okay. I'll see you all.